Okay, so what I need you to do is I need you, once you get that done, to turn in your student journals to page 125. Okay, and I want you to listen to me as I talk about what this chapter is going to be like. This chapter is all about triangles, as will our chapters be when we get back from winter break. But this triangle chapter is going to be, well, we're first just going to talk about triangles. Then after Thanksgiving, we're going to talk about triangles being congruent. And I guess we'll sort of talk about that before Thanksgiving. But congruent triangles is what we're dealing with here. Okay. After Christmas, we'll talk about similar triangles, and we'll talk about some special properties of triangles. And then we're going to get into special right triangles. I mean, really, we have a lot of triangles in our future here. Okay. So on page 125, when we are talking about triangles, we have interior angles and exterior angles. What do you suppose interior angles mean?
On the inside. Oh, we're working with triangles.
I believe I spent 2 minutes talking about that. Brayden, what can you tell me about the 3 interior angles of a triangle?
I'll add up to 180.
Okay, our sum is 180 degrees.
Sam, I'll pay you.
125. So my child plays sports left-handed, left-footed, left everything, but he writes with his right. Weird.
I go for it.
I think that enough people like
Would
helped
you
him when
write
he was
right-handed?
like 2 with his right hand, to where he just, that's where how he learned to write.
Golf right into be the fat.
That is strange.
That seems very
I
weird.
cannot golf left-handed. I can't golf at all anyway, so.
So it doesn't matter. Maybe that's why. All right, what do you think exterior angles are? Hey, what do you think
I don't
exterior
know.
angles are?
Angles, outside angles, someone's 90, 180.
We're gonna not. Okay. So let's maybe talk about this whole like exterior angles thing. Okay. So here's a triangle, and I'm going to highlight in pink my 3 interior angles. And then here I have an exterior angle, where basically I took my triangle and I made one side keep going, right? That's an exterior angle. Okay. Now let's pretend, well, first let's do this. What is true about this pink and this blue angle specifically? They are adjacent. What else? They add up to 180. They're supplementary,
Linear pair.
which means they're a linear pair. Okay. Now, let's suppose that this angle is 80 degrees and this angle is 40 degrees. Okay, so you're saying this one's 60, which makes that blue one what?
120.
Nope.
Supplementary definition.
Okay,
Oh, wait.
Notice.
Oh, adjacent. Is it adjacent?
So this guy, these two add up to this guy.
Yeah.
Let's talk about why. 3 angles of a triangle add up to
180.
180. These 2 angles are going to add up to
180.
180. So whatever this angle is, the leftover has to equal that. Okay.
Wow. Yeah.
Isn't that
That's
cool?
true.
Hey, no proofs until after Thanksgiving.
Oh.
Uh-huh.
Yeah.
Uh-huh.
That's a week and a half.
All right, so let's talk about the different ways to classify triangles. Kind of boring, but that's fine. We'll accept boring on a Monday. So there are 3 ways to classify a triangle by its sides. There is a scalene triangle. That means no sides are congruent. All 3 sides are different lengths. There is an isosceles triangle, where how many sides are congruent? 2. Equilateral. 3 sides are congruent. Okay. There are also 4 ways to classify a triangle by its angles. Acute. Oh, it's so cute because all of the angles are acute. Okay. Right triangle. One and only one. There's another one. One angle is a 90-degree angle. Obtuse, one angle is obtuse. Okay. And then this is, it goes hand in hand, but if we have an equilateral triangle, if all 3 sides are the same, all 3 angles are the same, and that's called an equiangular. It's a weird word, isn't it? Okay. So I'm going to give you a triangle, and we are going to decide what its classification is by both its sides and its angles. Are you ready? Draw the most beautifulest triangles known. There's my beautiful triangle. Sam, what is it?
Right triangle. I saw it.
Thank you. I love that your class keeps you in check.
I said the wrong one.
You did. And they let you know about it, didn't they? He was judging in his mind, though. Seriously. Why?
No.
Did you just say triangular?
And I said the wrong thing.
It's close. Is there a T in it? Equal. Okay. So we have equiangular and equilateral. If you called this equilateral acute, I would totally be okay with that. Harvey, what are all 3 of those angles? What measure? Yep. So what are they? How many degrees?
60.
Yes. If they're all 3 the same, they're all 360 degrees. Okay.
368.
This is when we just ignore him. Okay, what is this? Scalene. Obtuse. Nice. How do we know that it's scalene?
There's none of them.
None of the sides are marked that they're the same. Okay, know what happens when you assume. All right, so let's go ahead and turn the page and let's talk about the triangle sum theorem officially. Okay, we know that 3 angles of a triangle have to add up to 180 degrees. So if I had a triangle where I had 87, 62, and X as my 3 angles, what would I do to find X? Add them up, knowing that they equal 180 degrees.
87, 62.
31. Okay. So we know this is an acute triangle because all 3 angles are acute. Aw, it's cute.
You have to say obtuse and then.
Didn't everyone have a math teacher with a bunch
You have
of
to go obtuse.
No.
Only the cool ones.
You know
I
what I'm
swear we
talking about,
did.
right? You
What?
have to say it like,
Trina.
like, you know, obtuse, acute. Like obtuse, you have to say in a big voice and remember it's like obtuse.
What?
Yeah, that's it.
Then how do I solve for X?
2x plus 24 plus x plus 90 equals 180.
That's 21.
Oh,
It's fine.
I also thought it was 24. That's 21.
It's a 21.
stop it, guys. Before I make
Make you what? Oh, okay. So 3X equals 51 question mark?
No.
Yeah, it's 51.
No, 59.
Oh, it's 51.
yeah, 59.
No, not 59. 69.
I did have one.
Stop being immature, Brandon.
Thank
you.
Brayden, what's X?
Wait, I see, it's 23.
Thank you. Brayden, just don't react. That's what he wanted. Okay, so question. Could I have made this just a little bit shorter of a problem? You guys, if this is a 90-degree angle, do I have to add all of these up to be 180?
Oh.
That needs to be
90.
We know that these 2 add up to be 90,
Yeah, 1 second.
and that's fine to do also. Okay.
Wait,
Will we have
it-
to say that
has
we
there
do
ever
that?
been an instance where the angle is 90 degrees, but the 2 other ones are 45?
It's not a triangle.
This guy is 23 degrees.
It would just be
They weren't
scaling.
congruent.
It would just be scaling. Okay.
Okay. If a right triangle has 45-degree angles, then what kind of triangle is it?
Equilateral base.
Isosceles, very good.
Oh, 45, 45. That means.
We're gonna talk more about that Thursday. All right, so we kind of talked about this before, but we're gonna officially do some problems with it. If we have two angles in our triangle, we know that they add up to that exterior angle of the third. Okay, right? We talked about this. Yes, Miss Hellman.
Yeah.
All right, so this exterior angle that I'm drawing is 123 degrees. This angle has a measure of X, and this angle has a measure of 62 degrees. So what this theorem says, instead of me going through the work of finding that third interior angle and then solving for X, what we can do is we can say that X plus 62 equals 123. Okay, one more problem and then I'll let you start your homework.
Yeah.
What's wrong? Oh. All right, so how do I set this up? Good, X plus 80. These two internal angles add up to our external angle. So X plus 80 equals 3X minus 22, which means 2X equals 102, or X equals 51. Are you okay? I don't know if you are. All right.
51.
Okay, so I want you to go ahead and look at page 127 in your student journal. Okay, and I want to talk about number 4. How are you going to be able to figure out number 4? I want to know if we have well, I need you to tell me by its sides if it is scalene, isosceles, or equilateral, and then you need to tell me if it's a right triangle. So what are some options you have to figure out if it's isosceles, scalene, or equilateral? You have 3 coordinates.
So just to figure out if it's isosceles or equilateral, we can look at the little marks on the sides or the sides.
Well, it's 3 coordinates. So you're not gonna know that. It's 3 coordinates and number 4.
If some of them are equal to each other, then the angles are congruent, and then we can use that.
Okay, so it's sides. How do we figure out if 2 sides are the same length?
A distance formula.
Oh, so what are you gonna have to do? The distance formula? 3 times. Then you're also gonna have to determine if you have a right triangle. Any thoughts there? So you have two options. You can either use Pythagorean theorem, if you remember it, or you can look at the slopes.
Like.
And if you have perpendicular slopes, right, they'd be opposite reciprocal. Okay, that would be your option there. So get started on page 127.
Plus like.
Not even close.